Woohoo! Hi everyone, welcome to another month of...
Hello? Oh, anyways, what are we doing?
Stop using your shell phone. Focus, we have a video here.
Focus, okay. Hi.
We are bringing you another episode of Science at the Skansie House here at the home of Harper Wild Watch in the heart of downtown Gig Harbor. This broadcast is brought to you by the Lodging Tax Advisory Committee. So we're so excited to bring you some seashell secrets.
From the Salish Sea.
There it is. All the S's.
Yes. So many S's. So yeah, we're gonna delight you with some fun facts about seashells that you may or may not know. A lot of them I think are new to us just prior to doing some investigation and preparation for this. So I think we'll kind of start with some anatomy of shells. We'll talk about some common ones we find here in the Salish Sea. And then we have some delightful little tidbits to share with you, of course, along the way.
Before we get started, feel free to post in the comments where you are watching from. That's fun information for us to know. And maybe post how many people are watching with you. You know, we only ever see how many devices watch, but you know, if there's more people gathered around your screen, we want to know that too.
Absolutely. And of course, if you have any questions along the way, we'll do our best to see and notice those and answer them as we go. So.
All right, so Sina, what's a shell?
Well, it's something we should celebrate because they're so amazing. It's an important part of a lot of our bivalves that we find here in the Salish Sea, but as well as a lot of other creatures. A lot of animals happen to have shells, and so it's a cool adaptation that's great for protection as well as identification. I think that's one of my favorite things is you can identify a clam by their shells.
And so we generally see shells in invertebrate animals. So you and I, being vertebrates, we have our skeleton on the inside, our hard skull, like the skulls behind me here. We have the skeleton of all of our bones. But the animals that have a hard outer shell that we think of as being like shellfish, generally are invertebrates. So they don't have a backbone and their protection is on the outside of their body. Shells are great as a form of protection because they can be very, very hard and sturdy and strong. But they can also be limiting as well because they're heavy and it takes a lot of energy to produce these and to move them around if the animal is mobile. So let's talk a little bit about how shells are made. Most of the shells that we're going to talk about today come from the group known as the mollusks. Now, a person that studies mollusks is called a malacologist.
We didn't know that before we started today.
A malacologist is a person who studies mollusks. I think molluscologist
definitely has a better ring.
Yes, catchier. Molluscologist. Yeah. Anyway,
but a malacologist.
A malacologist is the name for a scientist who studies exclusively the phylum Mollusca. Mollusks have a very varied body, different types, and you're probably familiar with lots of them. We're talking the bivalves, so clams and oysters, the two-shelled organisms. We have the singular-celled organisms like limpets. We have gastropods, which are the snail or the stomach-footed, the snails that we know of. We also have the ones that don't have a shell any longer, things like octopus, the cephalopods, nudibranchs, which is like a slug. So we've got a wide variety of body types, everything from squishy octopus to really hard protected snails. Mm-hmm. And what we're gonna try to show you is some of the variety that we have here in the Salish Sea, as well as in other places, because shells are something that's been collected for thousands of years. There's a lot of shells out there, and we have some really cool shell collections here in our possession. But there are a couple of animal groups that make shells that aren't mollusks.
What?
Like this one, for example. If I came up across this on the beach, I would say, without a doubt, yes, this is a shell. It's hard, it's made of calcium, it's white, and it's found on the beach. This is the shell of a animal. This one's actually from Fox Island, from the bridge. This is one that was growing there. years and years and years ago. And this is a barnacle. This is a giant barnacle shell. And barnacles are related to crabs and shrimp, which is kind of strange and weird to think about. But if you look at a crab shell, on the outside of their body, they have this hard skeleton. Now they have jointed legs and they're very mobile and can, move around from place to place, but they have to shed this outer suit of armor in order to grow.
So we'd like to mention that no crabs were harmed in the filming of this video. These are indeed just molts. Rachel was talking about shelled animals, and I noticed on the barnacle, there's even another category of
Thank you
shelled
for noticing
organisms.
that.
This is the calcareous tube worm, which kind of encrusts on things like other shells as well as rocks. So worms like this polychaete here also form shells. So
the term
variety.
shellfish is one that drives biologists crazy because it's not a scientific grouping. A worm is not related to a crab, is not related to a snail or a gooey duck. So
also not a real gooey duck.
Not a real gooey duck, no. We do have a gooey duck shell though. So I've got this cool shell. But let's start with maybe, do you want to do snails or do you want to clams first?
I think I feel like I like clams because I think.
Are you hungry? Is that why you like clams?
Yeah. Oh, my lovely landlord did just make me razor clam chowder and left it on the porch. So, woo-hoo, shout out to Cindy. I don't think we have any razor clam shells though. That would be an interesting one to feature.
Yeah.
That's more on the coast. Sometimes we get a similar species called I think they're like jackknife.
Yeah, jackknife.
They're a lot smaller. But this nice big horse clam shell here, or also known as a fat gaper, is a nice big shell.
Sounds like an insult.
So rude. But just kind of a nice shell to talk
shell too.
about some of those just basic anatomy pieces of our bivalves. So the two shelled bits. There's, of course, the beginning of all clam species starts with the umbo, and that's that kind of the spot where all of these rings start forming. And so
it's like the origin of the
origin. So I know with like baby oysters, they look like a capital letter D as they're swimming around finding somewhere to settle, and then that will start growing their shell. And so depending on the species of clam, they'll form kind of different rings. So this horse clam here just has the nice concentric rings. If I were to compare that to like our native little neck clam, let's get that contrast going.
Different.
Yeah, it has some radial lines.
It kind of has them both directions.
As well as the concentric rings. Yep, so it has both of them. And then if we were to compare that to more of our heart cockle,
ooh, nice.
They really have the dramatic radial lines, as well as, again, some of those concentric patterns too. Another thing to look at when identifying these bivalves is the hinged teeth. And so
teeth?
Yes, clams have teeth.
What?
And so looking at that can help identify, as well as the hinge. I think I have a nice bit of hinge on this butter clam here.
Butter clams have big
have a really big dark hinge. That seeing that with the concentric rings is your clue that even though this is tiny and has some similarities to say our little neck clam, you can see the little neck has the radial rings too. And not as dramatic of a hinge, although this does look more dramatic because it's glued together. So little throwing us off a bit.
A lot of our shells were inherited from other people. We tend to not take shells from the beach because those shells are needed for both, they'll be kind of recycled for the next generation of bivalves and gastropods that are making their shells, as well as they can become food and homes and structure for lots of other animals. So a lot of the shells that we have in our collection have been given to us from other sources. So because of that, I also have a lot of non-native shells. So here's one of my non-native bivalves. This is a scallop. And this one's from the Indo-Pacific somewhere. So I am not 100% on the species. I just know it's a scallop. This little fin here on the side actually helps to steer this little bivalve as it swims. So in life, that scallop can clap its little valves, the two shells together, and it just kind of like squirts through the water and settles somewhere.
I think I have a video that I need to process and post of scallops, because we do have scallop species here in the Salish Sea.
And they swim.
And it is like the most delightful, silly thing. I love seeing a giant Pacific octopus, but like when a scallop just like flutters by your face out of nowhere, it's the most surprising delight. Like I'm surprised I keep my regulator in, because I start laughing and giggling so hard every time I see it. But,
I love it.
They're delightful.
So yeah, so that's my only tropical bivalve shell. Everything else I have is like a snail.
And then when we're bivalve, they can have some pretty dramatic differences. A lot of these, you're like, oh my gosh, how do I tell these apart? Like, okay, sure, they look different, but like they're so similar. Oh, there's a lot to keep track of. But then you get things like the Pittock clam, which has these wild ridges on the edge that can actually corkscrew through hard substrates like clay and even rock. So they just kind of...
It's like a little countersunk drill that just wedges down in there. And this is a species of clam that until a couple of years ago, I had never seen the live animal shell. We see the Pittock siphons, the section, the fleshy part that's going to stick up out of the shell to grab plankton from the water and squirt water back out. And you can see this at a lot of our beaches. Penrose and Kobuchak have a lot of Pittocks, as well as Manchester State Park. All of them have these really cool Pittocks. And I had never seen the shell of the animal, because even when they die, the shells remain lodged in the rock or the mud or the clay. And so it's pretty rare to find an actual Pittock clam. But somebody was out at the beach and they had a shovel, and they sunk the shovel down into the clay, and they busted off a chunk of the clay, and we were able to see the clam living on the inside. And this is a clam that cannot fit all the way inside of its shell. So in life, an animal this big is gonna have a siphon that's something like that in size.
Let's think about the
quite large. It's gonna stick and extend up. And then they also have a foot that extends downward as well, which is just really cool to see on these Pittock clams.
And I mean, really just looking, there's some similarities, but Pittock clams definitely get mistaken for gooey ducks a lot. And so then we get to the siphon identification, which we're not going to talk about at all today, because we don't
have any siphons to show you. We only have the shells that are left here. Yeah. But for the gooey duck clams, the ones that people really confuse with horse clams a lot is we have kind of these two, and it's the shape that gives them away. So on the gooey duck, they're going to have this squared off chunk of it, and that's the opening. So if you can imagine, straight on, this is not going to totally close. Same thing with the horse clam. It's not going to totally close around their siphon either, but the gooey has the flattened section, and the horse clam has the rounded section. So that's how I tell the difference. The gooey duck usually is also kind of really straight up and down, and this one is more curved. So rectangle-ish shell, roundish shell.
Really large.
And both big, yes. These are huge clams.
Yeah. And then...
Let's talk
snails?
Yeah, let's talk snails. So of the bivalves have the two shells. Of the rest of the mollusks, most of them have one shell, and the biggest group is definitely the gastropods. So gastropod means stomach foot, and they get that name because their mouth and their foot are basically all that creeps along the substrate. So we're talking about things like snails that have a singular shell that grows and spirals with the animal, like these right here. We have these weird ones that we don't have here in the Pacific Northwest called cowries. They have a singular shell with this kind of weird, funky opening. I wish we had cowries here because they're awesome, but they're more tropical.
Are those the ones that you're not supposed to touch?
No, that's a cone snail.
Oh.
I don't have any cone snail shells. Just kidding, I lied. I do have some cone snail shells.
Thank you, Mike Behrens, for this generous shell collection donation.
So, up in here, these ones, the ones that are shaped like a cone, oddly enough, they're very well named.
Gosh.
These are cone snails, and they're a venomous type of snail that has a proboscis, this nose-like little stylus that sticks out and stabs their prey, and they have a neurotoxin, a very, very potent neurotoxin. And that's how a very slow snail can eat things like fish, which is just wild. But we don't have them here, so you don't have to worry about it. All the snails that we have in the Puget Sound and Salish Sea area are handleable. There's nothing here that
They're
can hurt
even probably in most cases pretty delicious.
Yeah.
So
Yeah.
you see a lot of people out harvesting. So if that's something you're interested in, always check the shellfish regulations and make sure you have a license when collecting your shellfish.
Yes. Okay. So let's start with some of our biggest and most well-known snails. This is the shell of the moon snail, Lewis's moon snail, and quite often I get people exclaiming, "Look at its eye!" No, it's just the whorl on the shell. It's this kind of beautiful pattern, and you can see, just like the umbo on the clam, the origin of the growth is in the center, and then they're going to grow outward. And this shell, I love it because it actually shows a growth line here and here, and that's 1 year's growth. This shows how the shell growth slows down in the winter time when the water temperature's cool. They're moving around less, they're eating less, and then when the spring months and summer months come back along, they start eating even more. And the moon snail shells can house the entire animal, but when they're alive, when they're out and crawling around, their mantle, their foot, actually extends up and out and over the shell. So quite often when we find these animals, you might only see just a little tiny bit of the top of the shell, and then the slimy foot of that animal is growing around it. And we have lots of videos about moon snails, both on our YouTube page, our TikTok channel, and here on Facebook as well. So you should check those out.
We like to, when we're looking for them, we like to howl to the moon, and then that's a guaranteed way to help you find them.
Yeah,
Not
yeah,
at
for
all.
sure.
Not at all. No, sorry. Another cool snail species we see in the Puget Sound Salish Sea is the Frilled Dog Winkle.
And look at those frills.
Yeah, this one is a very frilly Frilled Dog Winkle. I often think it sounds like I'm just making things up when I'm talking about this
It sounds like
snail.
a very Harry Potter-esque like creature.
But I know there's been some thoughts that the frilliness of the shell helps deter predation from sea stars. They've done studies where they actually file down the frills, and the snail's more likely to be consumed when its shell is nice and smooth, probably because the sea star can grab it with its little tube feet more easily. So,
and this is an interesting one because the snail grows those frills in the presence of that predator. So if you keep the two snails in captivity with no sea stars, they actually have a smoother shell overall, which is just wild that they can kind of control that. In the presence of the predator, they armor themselves and get really frilly, which is great. And this is a species that's really favored by the hermit crabs. Again, not a type of shellfish, not a type of mollusk, but an animal that takes advantage of the really cool shell and very hard armoring of the snail shells. And they will move into those shells as well.
Yeah, and they'll just kind of slide their soft abdomen inside, and then they often have a larger pincher that serves as a trapdoor for those shells.
Yeah, which is nice. Snail shells come in like a huge variety of shapes and colors. We have these very, very pointy snail shells. This is not a native species, but it's quite pretty on the inside.
We kind of have a version that's smaller.
Yeah, we have a little jewel top snail,
snail,
but I haven't been able to find one that's not occupied by a snail or by the hermit crab. So, and then we have these cool murex snails, which have this really long leading edge. These are snails that live in a very sandy habitat, and they'll
not the Puget Sound.
not here. Yeah, these are like Florida type snails.
What's the adaptation for sandy? Weird.
It helps keep them from tipping around. I don't know.
Oh.
I'm not an expert on tropical snails by any means. But this one is my favorite snail shell, and this is one that's been polished artificially. So this is the color of the material on the underside. The actual snail shell is pretty rough actually and looks a lot more like this. So this is a native species. This is a red abalone, and they're really pretty and like iridescent on the inside. The outside is much rougher. So in this one, it's been polished, and that roughness has been sort of sanded away.
I like the abalone because their little antennas can stick out the holes.
It's really cute.
They're really cute. And that's a species that I know there's a lot of work being done to better understand them and help protect them, because
they're in
not
decline.
doing so
They're a threatened and endangered species. So there's been some captive breeding efforts where scientists are reproducing them in labs, letting them grow to be a slightly larger size than they would be when they first settle out in the wild, and then they release them. And they're predators, they're herbivores, they're grazers. They're scraping along with this chainsaw radula tongue to take algae off the rocks, and they're a really cool species.
Yeah. And unfortunately, they're both beautiful and delicious.
Yep.
And people just, come on, people. Let's do better.
You can't avoid them. Are there any? Oh, yeah, we forgot to talk about. So this is a type of snail shell, but not a gastropod like the spiral-shelled animals. This is the singular shelled animals. These are from limpets. And these are really ancient species. They've been around for millions and millions of years in the fossil record. They extend back. They're one of the oldest animals that we have in the fossil record, and they haven't really changed much in the past several hundred million years, which just goes to show this is a really great design for living in the intertidal and subtidal areas.
Why are they not a gastropod?
Because they're not a gastropod. They're different.
So they're different.
Limpets. Okay.
Yeah.
I'm gonna go down the mollusk family tree. Wait. There's an image here. Hold on.
We're gonna find our. We have to.
Good scientists always have their research handy, right?
I'm about to learn something new.
You're about to learn something new. So there's the Polyplacophoras, which are the chitons, which have many shells.
That would be. I
know.
Kind of trying to dig around to find some chitin
shells are hard to find because once the animal dies, all of these 8 plates they're not held together anymore. So it's really hard to find one unless you find like a dead one.
Yeah, I was like, if they are held together, that's gross because it's gonna be stinky and meaty and. Ugh.
Okay, now I don't know. Oh, here it is. Okay.
Oh, nice.
It's in the big book.
The big book.
Wait. Okay, so you probably can't read it, but that's a cladogram showing the different relatedness of the species. So down here, the Monoplacophora and the Polyplacophoras, those are the ancient ones, chitons and limpets.
Man, it's been a long time since I've taken invertebrate zoology.
And then the gastropods are way up here with these weird cephalopods and gastropods. They're up here. They're different. They're not related very much at all. But convergent evolution has shown that they are both very successful having that singular foot and the scraping radula. There you have
Twirly shell and torsion. Oh, torsion! We'll talk about that another day.
Yeah.
But
so there you go.
Yeah. And then of course there's a bunch of different like teeny tiny little snail species from the checkered periwinkles to the dove snails to
there's so many, the lacuna snails, but they're itty bitty and they're not very good to show you.
Yeah.
But
you'll have to join us on a beach, a digital beach walk soon, and we'll use our camera zoom to really show off those other shell creatures.
Right now is a great time to, if you get a good low tide, to go out and explore because all the mollusks are pretty much reproducing right now through the summer months. So we see a lot of that type of behavior, whether we're seeing the little egg cases or we're seeing big egg cases in the case of the moon snail, or occasionally we'll catch the plankton when we do a plankton tow and we'll see some larval forms of all of these animals. It can be really, really pretty cool.
Yeah.
What else do we want to talk about? You want to talk about oysters for a second?
I did notice, I was like, the oyster shells are way over there. I couldn't reach them.
Have some oyster shells for you.
Yeah, we have some Japanese oysters, and I've been doing a lot of work through our community science efforts in looking at oysters, because this is a species that we've seen naturally start to recruit or populate our beaches, partially because the water in the Puget Sound is getting a little bit warm enough for these to go, yay, let's have babies. And so it's fun to see them on the beaches. There's also the native oyster, the Olympia oyster, which we don't have a shell example of because we don't see them a lot in the Puget Sound.
And they're usually freaking glued to a rock.
Yeah.
I'm not going to carry a big rock home with me just for the oyster shell.
Yeah, but they have some cool differences. But you can see, I love this example because oysters like living on other oysters. So a good practice if you are harvesting the Japanese oysters out on the beaches, which they're planted there for that purpose often, you actually have to leave the shells on the beach. And that kind of oyster reef habitat ideally will beget more oysters. So if these oysters are on the beach, the baby oysters will be like, oh,
on their
look at
shells.
this beautiful place. I'm anthropomorphizing a little bit, but you know, they're like,
You don't
okay,
think
if
larval
you can
oysters
survive
are
here,
having a
I can
conversation?
survive here. Let's go. And so
It's a good strategy. It
yeah.
works.
And hopefully we're doing some work out at Penrose to try and restore some native oyster populations. So far, you'll have to stay tuned for that, but we have a lot of hungry crabs out there.
We're still in the
unfortunately.
data collection phase of that research project, so
Yeah.
this is pretty great.
And this is another species that kind of has that purple tint on some of the insides. I don't know if that one shows it. Of course, that gets eroded over time, so that's not always a good clue for identification. But that's something that can be helpful if you do find a shell on the beach. Looking at the outside as well as the inside can help give you some clues as to what this creature might actually be.
So, speaking of oysters, do we have any pearls that form here in
Ooh.
our species of oysters?
We do, but I'm going to turn it back to you to tell us more about pearls.
We do. They're not very exciting because our native oyster, the Olympia oyster, as well as the Japanese oyster, they're not super shiny on the inside. And pearls are made out of shells that are secreted by the mantle of the animal. So what happens is an irritant, usually a grain of sand or a little bit of something, gets on the inside. And that irritates the animal that's soft body. They don't want a sharp granular piece of sand poking in their insides. And so they wall it off. They protect it with the only material that they have, which is the shell. So they'll take the calcium carbonate that they use for shell building, and they'll wall it around that little piece of sand. So humans have figured out that if we have oysters and we want pearls, if you just stick a little piece of sand, inject it into the animal, in a couple of months you can get a pearl from it. But our oysters, they do produce pearls, but they're pretty rare. And I've seen one that was pretty big, and it's about this big, and it just looked like a white marble. So it wasn't shiny. It didn't have that beautiful luster that pearls are kind of known for. But other animals, other clams, the giant clams do make huge pearls, and there's a number of other oyster species that make them, including freshwater oysters can also make pearls as well. So we have a giant clam. This is a giant tridacnid clam. They get huge. This one's a baby.
Very tiny one.
But they are big enough that I could fit inside one of their shells when they're full grown. So that kind of gives you an idea of the size of them. They're quite large. And the world's largest pearl was recently discovered in the Philippines by a gentleman who found it and hid it underneath his bed. It weighed over 75 pounds and was huge. Previous to that, the largest shell was about 14 pounds and like 2 foot in diameter or so. And that was valued at like 35 million. So you can imagine how much more valuable one that weighed 75 pounds is.
Wild.
But the shell material, basically the mother of the pearl, is what the pearl would look like. So if an abalone made pearls, it would look shiny and reflective like that.
Does an abalone make pearls?
Not that I know of.
They're just like, get out of here, sand.
I mean, they kind of could, but there's not really like an inlet. Like a
Yeah.
bivalve has the 2 shells, and then there's like space for organs on the inside. Yeah, that's a good question. But there you go. Hopefully all of our pearls of wisdom about shells and shell things. If you do have some shells at your house and you want to post a photo in the comments as soon as the live video is over, go ahead and do that, and we can identify them for you.
Or at least do our best.
Yeah, at least do our best. There's no guarantees we will ever be able to identify. I still have a couple of shells that I found locally that are totally stumped me. Some limpets that I'm like, I have no idea what animal this is.
Limpets are hard.
Limpets are hard.
There's a bunch of them.
Yeah. Unless it has a keyhole, and then it's really easy. It's a keyhole limpet.
Yeah, there you have it.
But there you have it. So those are all the shell things that we know. Stay tuned for another fun Science at the Skansie House next month. We also have some cool low tide beach programs coming up for those of you who are students or who know teachers. You can send them over to our website, harborwildwatch.org, for information on how to sign up for those programs. You could also email me, rachel@harborwildwatch.org is how you get a hold of me to schedule those one-on-one cool Zoom interactions with your class and the low tide beach walks that we're doing.
Totally. We also have a great cocktails and fishtails presentation coming up this month. It'll be with Tim White talking about how tracking fish, which includes, I'm like, how do we say this cooler? He's tracking sharks, he's tracking tuna, and then also tracking fishing vessels and kind of looking how that interaction might better inform conservation and management practices. So if you want to come learn about sharks, tune into Cocktails and Fishtails this month. What else is happening?
Oh, we have Earth Day this month. April is the month that we celebrate Earth Day on April 22nd. And we've got a really, really fun presentation with the staff of Harbor Wild Watch talking about the stories that we have to tell all about the Salish Sea. So we want to tune in for that.
A lot of stories.
Like everything from embarrassing moments to heartwarming, feel-good moments.
Oh, yeah. We'll cover it all. Dead things. We'll talk about a lot of dead things.
Categories.
But it's going to be great. And also a Blue Water Task Force sampling. I think there's just one more after this. So we partner up with the South Sound Surf Rider group to monitor water quality at some local recreation sites. So we'll do a live beach walk from there, and maybe if we're lucky, we'll even sneak in a little bonus live from the lab. So,
ooh, yeah, that would be fun.
I'll see what I can
show some scientists in action.
Yeah, exactly.
That's great. Thank you to all of you that have liked and shared and commented both on this live stream and our regular posts. That really helps to get our message of stewardship and conservation of the Salish Sea out to as many people as possible. And a special thank you to anyone who's donated to our organization. We are a nonprofit group, and your donations directly support the programming that we are able to do to continue to provide cool learning opportunities to the people of our community and beyond. So thank you to everyone for tuning in. Remember, leave shells on the beach when you find them so that other animals have a good home.
Don't be shellfish.
Don't be shellfish, as Stina says. It wouldn't be a Science at the Skansie House without at least a couple of
terrible puns.
Terrible puns.
I'm so sorry. Anyways, yeah, thank you all so much for tuning in, and we'll catch you on a digital program in the future.
Take care.
Learn, have fun.